In today's video, what we're going to be going over is how a 4 and a 5 pin relay work, and the way that you can know if your relay is defective or if it's a wiring issue onto the vehicle. In this training video, what we're going to be going over is ground side switch the relay operation. And my goal in this training video is to give you better knowledge on how a ground side switch relay is controlled and how it turns on the components when it is requested to do so. Now, the reason that I'm going over the ground side switch relay is because the ground side switch relay is the type of switching that is most commonly used in automotive applications. It's important to understand that a relay is just a mechanical switch that is electronically controlled, and the main function of a relay is to take a small amount of current and power up a component that uses a larger amount of current. So with that being said, we're going to get into how the relay is configured, and then we're going to get into how the relay is operated. So to begin with, you gotta think of a relay as two separate components working together. So if I would come and I would take and I would draw a line through the center of the relay, you could see that we have a coil side and then we have a switch side. Now, the side with the coil onto it is going to be your control side, and your control side will, on a automotive application, will always be pins 85 and 86, and your switch side or your load side will always be pins 30 and 87. There are exceptions with 5-pin relays, but we're just going to be going over a 4-pin relay because it's just the easiest to understand, and the only difference between a 5-pin and a 4-pin is that they take and they would add a pin on this side and they call it 87A over here, and basically that would 87A constantly has power going to it, which then in turn could be used to like power up a security system or something of that nature, something that needs to be on at all times. Now, it's important to understand that when you have a component that is not turning on, there are basic checks that need to be done with the relay, and then also basic checks that need to be done at the relay pinouts, which will be either on the BCM, the IPM, or the junction block, or the fuse block, wherever that relay lives. Now, before we get into the basic checks, I'm gonna go and I'm gonna explain to you how a relay is powered, how a relay is grounded, and what happens when everything works the way it's supposed to. So if we come down here and we come down to the lower half of this 4-pin relay right here, if we come down here and we look at pins 85 and 30, pin 30 is connected directly to source voltage. Now, source voltage could be whatever. If it's a 5-volt source, a 6-volt source, 12-volt, it doesn't matter. It's going to be connected directly to source voltage, and it will always have power on it. Now, pin 85 will be connected to a switched source voltage. Now, when I say switched source voltage, the switching could be done by either a module, it could be done by the ignition switch, it could be done by a physical toggle switch, it doesn't matter, but 85 will end up being a switched source voltage, unless there is an exception. Well, there's actually a few exceptions, but the main exception that I'm gonna give you guys is on a horn circuit. When you guys go and you press your horn, regardless on if the key is on or if the key is off, your horn will always work. Now, the reason that your horn always works is because pins 85 and 30 onto a horn circuit are constantly powered, and then when you push on the horn, well, it grounds out pin 86, which is where I'm coming to now. Now, pin 86 is commanded to ground by a switch or a module. So either it's going to be your horn circuit, it could be your light switch, it could be your horn switch, it could be your light switch, it could be the PCM, it could be the ECM. Anything that can switch pin 86 to ground will in turn ground out pin 86. So when pin 85 gets source voltage and then the pin 86 gets grounded, a magnetic field is produced inside the coil. Now, when the magnetic field is produced inside the coil, it takes and it closes the switch. Now, since pin 30 is connected to source voltage, when the switch closes, it sends source voltage all the way through the wiring all the way up to the component, which would be on this side right here. And that is exactly how a relay operates, or how a relay is commanded to operate, I should say. Now I'm going to switch over to another image. As you can see here, I created this little drawing where I illustrate what happens when you basically like turn on your ignition switch, or when you try to command on your the cooling fan gets commanded on, or your blower motor gets commanded on. Basically it's going to be operated the exact same. So as you can see here, I have a battery. My battery is my source voltage, and if I follow my positive, it would go to either a power distribution module, PDM, or a junction block. Now from the junction block, the relay would sit inside of one of these, and 30 would be connected to power constantly. Now when you get into the vehicle, turn the ignition switch to the on position. What ends up happening is that you have power that goes down an ignition wire, and it goes into your PDM or your junction block, and it comes out and it powers up pin 85. Now when pin 85 is powered up, what ends up happening is that your VCM or ACM gets a signal and it will ground out pin 86. So then when pin 86 is grounded out, well, the power that is constantly on pin 30 is transferred over to pin 87, and then from pin 87 goes to your load device. And that is exactly how a relay works for an automotive application. Now don't forget, this is a ground side switch relay. There is a positive side switch relay, which is pretty much the operation of the relay is the exact same. It's just the configuration of the wiring is different. So with that being said, let's take an example. You have a cooling fan that's not working, and you're beginning your diagnosis of the cooling fan. So the first thing that you would want to check is basically your fuses to make sure that everything is powered up. And then I would go and I would take and check my relay. Now in order to check your relay, it's very simple. All you need to do is, we'll come back over to this guy. You're going to want to take and you're going to want to measure your resistance of your coil. Now, measuring the resistance of the coil isn't foolproof, but it gives you a good indication of the integrity of the coil of the relay. So you would take and you would take a multimeter, and you would set your multimeter to the ohms function. Now, when onto the ohms function, you would take your multimeter leads and you would put it across pins 85 and 86, and that would be your coil side. And then you would take and you would measure the resistance. Now you can normally find the specifications for the resistance in a manufacturer's into a shop manual, and then you would take those specifications and then you would compare them to what is in the shop manual. Now after you test the resistance of the coil, if it passes, you could take and you could add power to pin 85 and add a ground to pin 86. Now by doing so, you will energize the coil. And by energizing the coil, the switch should close. If the switch does not close, well, you just found your problem. If the switch does close, the next step would be to take and check continuity between pins 87 and 30. Now, if you have continuity, then your relay is more than likely good, and you don't have to go any farther onto testing your relay. Now, if you would take and the pins the switch would be closed and you would test for continuity and you would not get anything, then your relay switch side is no good, and then you would have to replace the relay. So now we're going to come back over here, and that would be for testing the relay. Now, we just tested the relay is testing fine. So what else could be the issue if my cooling fan is not turning on? Well, we could have either an issue on my power side or my control side, which would be my pin 86, or we could have an issue on the power side, or maybe it's even the component that's not working. But to eliminate the component, the easiest checks to do first would be at the relay, female pins, and the first thing that you would do is take your test light or multimeter, whichever one you want to pick, and test at pin 30. Now, when you're testing at pin 30, if you have power, great, you can move on to the next step. If you do not have power, you're going to have to stop and you're going to have to figure out why you don't have power. Maybe it's a blown fuse, it could be a corroded wire, it could be the junction block itself that's not sending out its power, so you're going to have to diagnose why it's not there. In this scenario, we're going to say that we have power at pin 30. Perfect. Next, we're going to come up to pin 85. Pin 85, when you're looking at your wiring diagram, it'll tell you that it is hot and on or run. And so you would come over to your ignition switch. You would take and turn your ignition switch to the on position, and you would test for power at pin 85 onto your junction block or your power distribution module, BCM, wherever the relay lives. So you would take and you would test for power on pin 85 with the ignition switch on. Do you have power? Yes or no? If you do, then you would go to the next step. And if you do not, then you would have to do the same steps or same diagnostics on to that you just did for that I just mentioned for pin 30. So you would have to check your fuses, you would have to check your PDM, your junction block, or what anything of that nature. Now we're gonna come over and we're gonna say, okay, my fan, I have power on pins 30 and 85. So the next step would be to check pin 86 for a control, which would either be from your PCM, your switch, BCM, wherever it's coming from. So sometimes you might actually have to take and bi-directionally control it, and sometimes you won't have to. If it's controlled through the BCM or ECM, you're gonna have to bi-directionally control it. And if you're able to bi-directionally control it, and at pin 86 you find that you have ground, then you would stop there and you would have to go and test your load device itself and the wiring leading up to your load device. And don't forget to always check your fuses first, because you can save yourself a lot of time if you don't check if you check your fuses first. So now we have control in this situation. We have control. If you did not have control, you would have to check your wiring, and you would have to check the control device. So whatever is connected to the control device. So you would also have to check your grounds, and for the BCM, the PCM, and all those areas. So in this scenario, pin 86 has ground. So our relay is good. Pin 30 has power at all times. Pin 85 has power when the ignition is on, and I am able to produce a ground all the way up to pin 86. So far it is looking more like if it's going to end up being a component or the wiring leading to the component. So, and that's basically how you would go about checking to see if it's going to be a component, wiring, relay, or a junction block or anything of that nature. So with that being said, I hope this information does help somebody, and if you guys like this video, please like, subscribe, comment, and I will see you guys next time.